Welcome, everyone. I see the room filling up here. We've got another minute or two. Give people a chance to get into the webinar, and let's kick it off. Randy, we'll give everyone one more minute. Okay, we'll get started here. Good afternoon, morning, or maybe evening if you're joining us from overseas. Thank you all for joining us today and taking an hour out of your busy schedule to listen in on our webinar, Horticultural LEDs, Fact versus Fiction, presented by Surna Cultivation Technologies and RSX Enterprises. Over the past 5 years, we've seen tremendous advancements in horticultural LEDs spurred by the growth of controlled environment agriculture and the indoor farming industry. That's both cannabis and non-cannabis food production. It seems as if a new LED lighting manufacturer arrives on the scene almost every day, so there's a lot of choices out there. As a consumer, how do you choose the right light for your operation? With all those choices, it's not an easy decision. So our goal today is to help you separate fact from fiction. And if we can impart even the smallest nugget of wisdom that helps make your LED lighting choice easier, it'll be a great webinar. Before we dive in, a couple of housekeeping items to cover. Remember, everyone will be receiving a recording of the webinar. Also a copy of the presentation, so don't worry about furiously taking notes while you're listening. At the end of the presentation, we will be asking you to fill out a survey. Please take a minute to do that. It helps us understand what we did well, where we can improve, so we can continue to bring you great content. And then finally, there will be a Q&A at the end of the webinar. If at any time during the presentation you have a question, please just type it into the chat box and we'll get to it in the Q&A at the end. So let's get into some quick introductions. My name is John Kozlowski. I'm VP of Sales for Surna Cultivation Technologies. For the past 20 plus years, I've been involved in the horticultural and CEA industries, both as a grower and a vendor supplying product to the industries. At Surna, we provide engineering design services, HVAC equipment, controls, benching, and other core components for CEA facilities, including LED lighting. I'm also joined today by Randy Shipley of RSX Enterprises. Randy, can you tell us a little bit about yourself and what RSX Enterprises does?
Yeah, well, I'm pleased to be on the board of Surna to start with as an outside independent director, and I've helped them with where they're going in lighting. But I have 5 years of LED lighting experience that comes from working with Lighting Sciences, which is one time was the largest manufacturer in North America for LEDs. And I learned from their top scientists who have worked with some of the top firms around the world on how LEDs work, and plant scientists. They had a horticultural division. And it became very similar to me. It was a very easy transition at that point. I'd had 15 years in the cannabis industry with multiple functions and different hats, but I have over 30 years in telecommunications, which everything's an electronics device. It's printed circuit boards, it's chips, it's how do you get the heat out of that product and how do you provide power to that product. So I've used that to go into LEDs and work with Surna to make sure that they're providing the right lights for the right clients, basically.
And I mean, I've learned a tremendous amount from you over the last couple of years. So first fact or fiction question for you, Randy. You look pretty buttoned up in your profile picture here, but are you rocking the ponytail still?
Yeah, you want to see
There it is. Yeah.
So those are my COVID curls that I grew with COVID. I decided I was going to stop shaving that head back there. So.
All right. All right. Well, glad you're here with me today. And so let's jump into the basics. And we want to set the table today with some basic definitions because there's a lot of acronyms out there used in the lighting world, so it can get confusing. So we've chose three of the most important, the three Ps, PAR, PPF, and PPFD. This might be a review for some of you, but I think it's important that we go through this because lighting manufacturers are using these terms, and to have this basis of information is important in understanding LED lighting. So let's start with PAR, or photosynthetically active radiation. It's part of the electromagnetic radiation spectrum that is useful to plants to activate photosynthesis. These wavelengths sit within the visible range of 400 to 700 nanometers, and plants absorb this light and turn it into energy. Science also tells us that different colors produce different effects in the plant, and more on this later. But next is PPF, or photosynthetic photon flux. And its value determines how much PAR is being produced by one lighting system or light over the period of a second. We've got to be careful in using this number to evaluate LEDs. We've seen this happen before. PPF is not the measurement of how much light is reaching the plant, just the amount that is being emitted by the fixture. And then finally, PPFD, or photosynthetic photon flux density. This is the measurement that's really important, right? Because it's PPFD that measures the photon that make it to the plant. It's the number of photons within the PAR zone that are hitting a point on the canopy each section. So that might have been a review for some of you. But Randy, next fact or fiction question for you. The light with the highest PPF, is that the best choice?
No, it's not actually, because it depends upon light distribution, distance to the canopy. A big part is the light distribution actually, because what you're trying to get is uniformity. If you can take a real and squint at the chart there, you'll see that there's a lot of numbers in that chart. The more uniform that is, the more uniform your canopy top will be, the more uniform the light is that your plant's getting. And if you have lights that, for example, put out a laser beam, they would only hit one point in that plant. So they could have a very high PPF at that level, PPFD at that level. They could have a high PPF output, but they wouldn't do anything for your canopy. So what you're trying to do is find a light that's got a good PPF, a good efficiency, and is actually able to provide you with a uniform PPFD based upon light distribution.
And so let's take a look at a couple light maps and talk about height and density. So these two light maps here, and we show some average PPFD over the canopy because this is where the rubber meets the road, right? Light mapping can be an invaluable tool in helping you assess a light's performance, not as a single fixture, but in a complete room design. At Surna, we're happy to map our lights for our clients, and any reputable LED manufacturer should be able to provide a light map customized to your facility. Randy, you and I encounter situations where growers have become so hyper-focused on a specific performance indicator that they forget the bigger picture. For instance, maybe just looking at PPF specifications of a light. Can you use that example to discuss the importance of, mounting height and lighting density in an overall design?
Yeah, the less beam angle is very, very important. So if you have a fixture that's very, very small, let's say you have a very small flashlight, you put it on the wall and you're very close to the wall, you'll find a very bright, intense circle at the wall. The farther you move away from that, the larger the circle grows and the less intense it becomes. So height and beam angle become very, very, very key. If you were to take 2 flashlights or 3 flashlights, you start to overlap lighting if you're coming back from them. And where you see the overlap, you'll see that the light becomes brighter. So when you're in a grow room, you're actually trying to overlap lighting and reduce light loss. So your light loss is really on the canopy as much as possible, but you're always going to have some light loss. And the reason we use these 2 as examples is, growers are used to growing with HPS. It's been very successful. We've been growing in Michigan, where we grow over there, for 15 years, and we started with HPS and was never a believer in LEDs. But HPS, you're actually able to get, typically you're going to have to be 3 feet above the canopy because of the heat the light puts out. It radiates heat. Nobody wants to touch an HPS light when it's on, or the bulb. And so you've got to keep it far enough away from the canopy. So growers, to get good quality, are used to having grown with averages of around 1100 PPFD. This is just to show you how much more PPFD you can get closer, but actually today's LEDs should be able to put out, if you're using a good product, should be able to put out about the same PPFD as an HPS light, but they will put out a higher PPF per fixture.
Mm-hmm. And I mean, that's where we like to start the conversation with clients is, do they have a goal for average PPFD, over the canopy? So if they don't have that goal in mind, they might be new to cultivation, you're recommending an average of 1100 PPFD over the canopy?
Yeah, I would say that that's a good minimum starting point to work with for commercial growers.
For commercial growers. That's cannabis specific. And is that for flowering?
Flowering? Yeah, every stage of the plant, the PPFD is going to be different. Every plant is going to be different. Lettuce, you typically are growing at 350 PPFD, I'm sorry, for lettuce. So every plant is different. Flowering plants and fruiting plants need more light. It's always comes down to, you can actually go and do the calculations and get DLI charts that are the light interval charts per plant. Those are readily available. But cannabis is a very, very high light consumption plant.
And can you tell us a little bit about the software that produces these maps? It's a great tool.
Yeah, so we use Loom Tools, which is the only horticultural lighting tool that's out there. If you ever get a lighting layout from somebody in horticulture and it's quoting lux or foot candles or something like that, it's an inaccurate measurement. You want to measure in PAR and in PPF, and Loom Tools takes what's called an IES file that's created by putting your light either within a sphere that captures all of the light and all of the beam angles, or done with a goniometer, I think is I always say that word wrong, there's too many O's in it. But you capture that light and then you put that into the software, and the software then can generate, based upon the exact beam angles and the amount of light, exactly what your lighting layout's going to give you, and can give you an exact PPFD based upon the height of the canopy to your light.
And you can start with an average PPFD, enter that into the software, and it'll produce that layout for you too.
Correct. You can say, here's my target, here's the light fixture, here's that IES file, how many lights do I need to do, and what's the spacing on them?
Yeah, I can't stress the importance of, if you're looking to make a purchase for an LED, make sure, you're assessing their performance with a light map. And again, any reputable LED manufacturer should be able to map that for you. So Randy,
I'll point out, John, just one thing. It gives you the layout as well. That's very,
correct.
very important to understand, because if you have to put 4-foot wide fixtures and put them every 3 feet on center, it's not going to work very well. They're going to be clashing all over each other. So it gives you the light layout and an optimal light layout to get to that optimal PPFD, and we'll give you the pictures of how that works as well.
Another question that we get routinely from growers considering LEDs is, where they should be hanging the light above the canopy. Now, obviously, there's single tier growing and double tier growing, and really with the advent of LED and the advancements, multi-level growing has really taken off. Do you have a recommendation for height above the canopy for mounting lights?
Yeah, there's a lot of variables, but plant age, if you were to use these lights and hang them over clones, you'd probably need to be 12 feet above the clones or more. So
Yeah.
it all depends upon the plant age to start with, your target for what you're trying to do. And then, but in flower, once you've done the transition from veg to flower, the nice thing about LEDs is you can dim them and keep the same spectrum. So you could, raise the light a little bit so you're getting away with less shock with LEDs than if you take a light that's under 450 micromoles and move it to 1100 under HPS. You can shock the plants, create a transition problem.
Mhm.
LEDs, you don't need to do that. So you just need to measure it and be careful. But in full flower, we're typically recommending that you want to be at least 1200 average PPFD and somewhere around 1400 parts per million for CO2 levels. And there's a lot of other variables as well that I think you'll go into later.
Yep. Okay, so factor fiction, because you mentioned HPS lighting earlier. Can LED lights put out more PPFD than HPS lighting?
So the answer is yes to both PPF and PPFD. Some of them require more wattage to put out more PPF, but today's best fixtures under 1700 or under 700 watts will put out more PPF than an HPS fixture will do. An HPS, a good Gavita with a brand new bulb in it, is going to be somewhere around 1800 total PPF. And you can get easily more than that. Like the 680 light that Surna is providing is providing about, I think, 1932 or something like that for the total PPF. So it can put out more PPF, and the result is you can get more PPFD that way as well.
Sure. And, still a hot topic is, converting over from HPS growing to LED growing. I'd have to say is that, in our day-to-day business, when we're helping clients design facilities, probably 90% of the facilities we're seeing are considering LED lighting over HPS. So LED lighting obviously has come a long way.
Yep.
So we want to introduce you to an amazing resource that's really helpful in comparing different LED lighting manufacturer specifications, and that's DLC, or Design Lights Consortium. Randy, can you help the listeners understand the value that DLC can bring in helping them compare, kind of apples to apples, manufacturer to manufacturer?
Yeah, I mean, for years, the utilities have relied on outside organizations to provide efficiencies of whether it's lighting or like Energy Star. If you're buying a water heater or a dishwasher, Energy Star is kind of the DLC of appliances. DLC has done lighting for just regular people lighting, and now has a horticultural division that they introduced about 3 years ago. And they give you third-party certification. So it takes out a lot of the claims that were being made by manufacturers of, hey, my PPF's more than your PPF or whatever that happened to be. And it's free to join. You can go in and sign up and get an account. You can look up any light that's on DLC. And I would strongly recommend that if the light's not on DLC for horticulture, you probably don't want to be considering it, because there's got to be a reason. It's very inexpensive. It does require having a third-party test done. But if the light's serious about being commercial, they should be on DLC, or there's something maybe that they don't want people to know.
Yeah, I can't stress enough the value of the resource. Please encourage you to hop on, type in DLC into the Google machine, create that free account, and you can pull up specs on 500 plus horticultural LEDs out there and compare apples to apples. So really helpful tool in doing that. So let's hop into our next topic, and that's spectrum, and that can be another confusing topic in the LED world, with lots of manufacturers throwing around terms like full spectrum or ideal spectrum. But let's have science tell us what our plant needs, not a lighting company. Two scientists that I always turn to are Bruce Bugbee of Utah State and Eric Runkle of Michigan State. Their research in plant lighting has been invaluable in helping us understand our plant's needs in regards to spectrum. I encourage you to take some time Check out their research. They both have great videos on YouTube, short watches that are a ton of great information. So definitely check those two guys out. But we want to talk about 4 colors today. And remember, PAR light falls between the wavelengths of 400 and 700 nanometers. Blue, between 400 and 500. Green and white between 500 and 600. Red between 600 and 700. And far red between 700 and 800. Now you'll probably notice there, well, far red is north of that 700, but we'll get to that. Randy, can you walk us through the significance of each color?
Yeah, I mean, it's very simple. There's a great spectrum video done by Bruce Bugbee, and he's the founder of Apogee Lighting as well, does the NASA science tests, and they're licensed with cannabis and hemp. But he recommends 20% blue, and he goes through exactly why. It stimulates the plant growth early on. It helps keep the plant from stretching, creates a better structure for the plant. Not enough blue, you're going to get a plant stretching to get blue. Too much blue, and you're going to get a plant that just sits on the ground and doesn't do anything. You can actually grow and go all the way through flower with red only, but you can't do that with blue. You need that red and that green and that white. So blue stimulates plant growth. Go to the 20% that Bugbee recommends. Green and white, they've done studies, and I think that if people want to get the study on this, they can go to info@surna.com and request it. Canopy penetration is important with green because green penetrates the entire leaf, whereas red and blue get blocked by the chlorophyll at the top of the plant. So that canopy penetration is very, very important, the amount of green. And their studies showed that anything over 30% kind of starts to have a declining value to almost no value if it gets to be too much. So, but green is used by the plant, unlike a lot of the old myths and facts and fiction. So that's a fiction. The green is not used by the plant. It is. And it's so important to be able to do your diagnosis of the plant health, pests, any sort of thing that's going on with the plant. Red is the most efficient energy source for the plant, and it's the most important for photosynthesis. And so you've got to get a balance of those. Far red has different values based upon different plants. We're not going to get into all of that today, but it does have enhanced cell expansion, which everybody immediately thinks, oh, that's really good. However, for cannabis, it's not so good because beyond enhanced cell expansion, you have to understand plant shape. And far red will get a shade avoidance plant like cannabis and others to stretch and grow. And if you're in racks in particular, that can be horrible to be overgrowing your levels and things. So far red, there's studies that are done that would say 1 to 6 for lettuce, and that's great. 300 micromoles of white spectrum and 50 micromoles of far red, and you'll increase your mass by 20 and 30%. But in cannabis and tomato, where the real studies have been done more are tomatoes and cucumbers, but cannabis is very similar, is it causes a lot of plant stretch. There's one interesting part of that, which is that far red can induce earlier flowering in cucumbers and tomatoes. But with cannabis, with the way that you flip to flower, there's yet no proof. There's no scientific test that says I'm going to increase my time to flower by 3 or 4 days and decrease my time to yield, because there's no test done yet on exactly how much far red would you apply. Too much far red and you could actually cause a lot of damage to the plant. So getting a true test done, they just don't really exist out there, except for what Eric Runkle's team has done in the leafy greens and in areas like that.
Yeah, this week I watched a great video from Eric Runkle on the importance of green light. And explaining how it was missed in the olden days with the old purple dinosaur LEDs, right? Yeah, that's right. And obviously, what you just explained about the best spectrum, you've integrated that into the design of your latest LED light, correct?
Yeah, I mean, I just went with what the scientists said. I wasn't going to try to reinvent the world. I'm not going to try to tune spectrum to do anything else. The plant grows really well if you can give it enough light. And when you're giving it enough light, what the scientists say is give it 20% blue, give it at least 30% green, and then the rest of it, if you can do it in red, fine. but as much red as you can give as long as you're meeting those two minimums that you're trying to do. So that's that 20% blue and 30% green.
Yeah, yeah. And so I do want to quickly discuss the use of different color chips in the manufacturing of LEDs and how they can affect the light's efficacy, right? And that's the measurement of how a fixture converts power to par. And, I think that, LED lighting manufacturers will, produce this efficacy rating that's sometimes a little misleading based on the type of color chips they're using. You tell us a little bit about that. And
yeah, I mean, the two leading name chips that are in the market today for horticulture is Samsung and Osram. They're not the only ones that can create this type of photon flux out of a chip. So, but because they're the most known names, I pulled up a couple of their specs. And if you went to the Samsung page, you'd see that they claim to put out 3.1 micromoles per joule for photon flux of efficacy. Now that's at a maximum use of the chip, and that's why I did the chart down below. Osram's at 4.42. But if you take a look at the chart below, what you realize is that the more wattage you run through there, the less efficient and the less flux you get per watt. So you've got to be very careful about that piece as well. But what this is just to show you is that photon flux efficacy on a white chip is much less than what it is on a red chip. So you can increase your overall PPE by increasing the number of red chips and then mixing in how you're going to do your white chips, basically. Mm-hmm. But one point that isn't on here is that a red chip will cost you 5 to 10 times as much as a white chip. So the manufacturers are trying to strive to get that balance, that 20% blue, 30% green, with a cost factor for the cultivators as well. And you can count the number of red chips. It's very easy.
Sure. And it's another area that we tend to see people considering LEDs get hyper focused on is the efficacy. Yep. And it doesn't necessarily mean just because it's the most efficient light that it's also providing the spectrum that you need for growing your plants.
Right. I just want to make sure that everybody understands that these photon flux efficacies are based upon like the best, the exact right amount of current to run through the LED, the exact right amount of forward voltage that's going through that LED, and it's going to vary based upon how the manufacturer designs their boards and chips.
Okay, so let's get into our next topic, which is certainly always at the top of everybody's list when it comes to LED lighting, and that's cost and ROI. Cannabis Business Times did a great state of lighting report in 2021. You could see the link to find that if you haven't seen it in the past. But 1/3 of growers indicate that they can't afford LEDs. Randy, do you think as they become more of a staple in indoor ag, we're going to see them become more affordable, just like we see in other areas of technology?
Well, there was a day when I took broadcast engineering where I spent $1,000 for a calculator, a scientific calculator, and now I carry a phone around with me that's got more power than computers, cameras. It does everything. LEDs are chips and printed circuit boards, just like all your electronic devices. You've seen the price come down significantly. You've seen the output go up significantly. So that conception or perception that you can't afford LEDs is probably not true, especially if you measure the overall ROI and take a look at the cost of the light, the cost to operate the light, the potential rebates. In fact, we found in some cases that after rebates, the LED light costs less upfront than the HPS light, as well as saving 40% potentially in HVAC costs. It's not a 1-to-1 ratio of what you save in HVAC, but if you're saving 40%, your overall operating costs are going to be less on the HVAC. Your install costs are going to be less. So the ROI, you need to take in a lot of different factors, including your local utility company, the cost of the LEDs that you're actually buying, or the LED fixture I meant. But the perception that LEDs are just too expensive is no longer true. We just had a group in Massachusetts that installed 100 lights, and got a $50,000 rebate. That came out to $500 a light. So that helps offset the cost by a lot. I think you can show that in some with the calculators and stuff that we use.
Mm-hmm. We have a lot of clients asking us about rebates. Typically, how long does that process take to get through a rebate and see that money provided by the utility?
The pre-approval is very, very quick, depending on the utility. Some are almost instantaneous within a couple of days. You want to get a pre-approval first, and then you're going to have an inspection done afterwards by the utility that shows that you actually installed those fixtures with that wattage on them. And then it'll typically, depending on the utility, 30 to 60 days for them to send you out the rebate.
Mm-hmm. And I mean, we're already seeing some states limit wattage per square foot of canopy, right? Massachusetts and Illinois, and we know that's coming down the pike in California. So it wouldn't be unreasonable to think that we're going to see more limits like that in other states.
Yeah, Illinois was done better than Massachusetts. Massachusetts is a hard wattage per square foot. Illinois is a maximum of 36 watts per square foot if you are not using lights listed on DLC. So if you're using a DLC light listed, you're able to increase wattage and able to actually increase your overall PPFD by going to a little bit higher watt because you're measuring that PPF per watt output. So
yeah. And again, I have to imagine we're going to see more states, implementing those type of regulations, not just around lighting energy use, but energy use in general.
Water and everything else. Illinois has probably got some of the most environmental restrictions of anybody or requests of anybody. So yeah, you'll see it. Water, I think, is going to be a big play as well.
So Randy, fact or fiction? It takes 3 to 4 years for ROI and LED lights versus less time for HPS lights.
That's fiction. Totally. In fact, you can, in some cases, depending upon your state and the size of your facility, which will, volume drives pricing down for the lights themselves, right? You can get an immediate payback on LEDs. You can have less infrastructure cost up front with LEDs, and typically because of what's being done with LEDs, they're actually a lower cost installation than HPS as well. So you need to factor in everything, and this calculator is actually just calculating your electrical savings and your annual cost and how much you're saving monthly and annually, what you might save in BTUs. It doesn't take into effect what you might be able to save as well with installation. Yeah,
of course. Yeah. And, for everyone attending the webinar, if you'd like this calculator sent to you, shoot us an email at info@surna.com or reach out to us through our website at surna.com, and we'll gladly share this LED ROI calculator with you. A great tool that we use quite often in helping our clients understand potential savings between HPS and LED.
Yeah, and the red just become different input numbers based upon your room and what you pay per kilowatt and how many hours a day you're going to run it, numbers of days you're going to use them, which is typically in cannabis pretty cool. If you can get a goal of getting to 365, you're a pretty happy camper. You're going to have some transition times between harvests and stuff, but you're going to be pretty close to that. So the reds just become inputs and everything else will auto calculate for you.
So let us know if you'd like to send that out. But, the next topic we want to talk about is integration. And so what do we mean by that? It's the cumulative effects of all of your inputs in your cultivation facility to really drive your plant's highest photosynthesis. So Randy, we've talked a lot about PPFD, obviously focused on LED lighting. But something we want to point out is that simply increasing PPFD will not generate better results on its own. And if you're thinking of increasing your lighting output, you need to consider other aspects of your grow, right? You want to elaborate on some of those other aspects that we consider?
Yeah, you want to balance. You know, CO2 is a key. If you're a home grower and not doing CO2, any light over 700 PPFD is pretty well wasted. So, you know, for a home grower, if they can get a light, they don't need to buy the most efficient light and the most expensive lights on the market, especially if they're not doing CO2. And then it also comes down to how you're managing your humidity, your temperature. You're trying to balance all of these factors. So any one factor on its own, if you don't give water to the plant's going to die, right? It doesn't matter how much light and CO2 you give it. So you want to balance all of these. Nutrients I look at as more of a little bit of plant steering, a little bit of plant health. It's a little bit like if you're working out and you're trying to gain a little bit of muscle mass, you want a little bit different vitamin. So I look at nutrients as kind of the vitamins for that final plant finishing, plant, you know, getting the most out of your plants. Whereas these others are just key. You can grow a plant, although you're not going to grow them very well without nitrogen, for example, right? It's not going to go anywhere. So you want to balance all of these. And that's the real key to it, is to create that environment where these are all in balance. And the more light you're going to add, the more you're going to have to balance some of these other areas. If you're at 1200 ppfd, you should be somewhere between 1200 and 1400 CO2 levels. Your watering rates are going to go up. Your plants are going to transpire more. You've got to watch your heat and humidity levels more. So very, very key that you balance all of these.
Yeah, and you know, with Surna's approach to these cultivation facilities, of course, we're not just selling lights. You know, we're really focused on the complete environmental control and design of these facilities, and of course, we're taking into consideration light, CO2, temperature, and humidity. You know, it's critical to perfect these environments to drive that little engine as efficiently as it possibly can go. And that's when you get the most out of your plant.
Yeah, I mean, if you had everything else right, but you were sitting your pots on a very cold floor, for example, so that your root zone was cold, you're not maximizing the output of that plant. You would want to get that temperature up on the roots as well. So again, balancing all of these things, very, very, very key.
Mm-hmm.
And there's just so much information available to help you get the right balance, whether you're a home grower or a commercial grower or whatever. There's just so much information. Use your PhD in Google and search and find it. Or the best for me is YouTube, because I'm very visual and I love some of the stuff that's done there by Bruce Bugby, by Eric Runkle, by Migro. There's some very, very good plant scientists, light scientists that can really get into the detail. I just take what the scientists have done and what they can show with studies, because I think that's the most important thing that you can do and use.
Yeah, it's amazing just the amount of research that's, you know, being involved in CEA for the last 20 years, the amount of research that's come out in the last 5, right? Information that's available out there that never was out there before. You know, my first foray into controlled environment agriculture was in hydroponics. And this was now, you know, 15, 18 years ago. I remember trying to Google hydroponics online and find information to help me build out my grow. And there was absolutely nothing out there. So everyone today is in a much better place in regards to access to some of this info. Before we get to the Q&A, we do want to touch on both sides of the story in regards to LED. Randy, what do you see clients having the biggest challenges in using LED lighting?
Understanding the other changes that you need to go along with LED lighting. Your ambient room temperature is typically kept higher because you get plants grow very well under HPS, which a lot of us have learned from experience, right? And it's because the HPS light puts out and radiates heat. So if you're to go directly under that lamp, it's going to be 84, 85 degrees, for example. Whereas the room temperature, to keep it that way, you've got to be at 75 to 77 degrees. So it's understanding a few of those little things in that transition, the most important of which is basically your heat and humidity levels. And realize that in the winter, you're probably going to heat more with LEDs than you would with HPS lights. Again, that radiated heat and things that are going on. So that transition of going from HPS to LED and the nuances of temperature, water, CO2 levels, all of those, there's a little bit of a transition, but it's all readily available information from the people that are doing your environment, or somebody like Surna that's done 800 facilities and knows from all of that information that's gained on with how you're growing, what medium you're growing in, what light you're growing in, what's the best way to set your environment. That'll get rid of some of those transition stages for you.
Yeah, and it wasn't that long ago where when we were designing HVAC systems for clients and they were coming to us using LED lighting, but wanting say a temperature set point of 70 degrees and relative humidity of 45%. And what we knew at the time, particularly in regards to vapor pressure deficit and with LED lighting, that is not going to produce the best grow environment for growing with LEDs.
Exactly.
But it's amazing how educated growers have become now, and now, yeah, we see growers coming to us with LEDs with temperatures upper 70s, lower 80s, and with higher RH.
And cooler temps at night will help bring the colors out and stuff when your plants are resting and stuff. We found out in Michigan we weren't able to do it as easily, so we used to go with our water buckets towards the last 2 weeks, and we'd put in gallon milk jugs filled with ice, into the water to bring the water temperature down to 50 to 55 degrees sometimes to help bring out some of the colors in the plants and stuff. There's some beautiful colors that you can see, if you're going to on social media all over the place. It's crazy.
Okay, so let's hop into our Q&A. I'm not seeing any questions popping up in the chat, but if anybody has any out there, please feel free to type them in there. We do have some questions that were sent from attendees prior to the webinar starting, so we'll dive right into those. So the first question is the person wanting to understand better LED's ability to penetrate deep into the canopy versus HPS.
So there's studies that show that over 30% of going over that with green, which is where you get your penetration, is not as effective. It's still effective. So the more green you get and yellow, you're going to get more canopy penetration. But no matter what, it all gets blocked if you're not defoliating and get rid of leaves, because everything will get absorbed by the leaves. So you got to be careful. So the question becomes, it's actually more effective to measure the canopy penetration by just simply measuring from the light to the top of the bench when there's no plants in there. That'll tell you exactly how much you're getting to that distance. And then what's more effective if you're trying to get a lower level canopy is to make sure you're defoliating and have a good pattern of defoliation, which in some cases can lead to plant shock and transition, and you lose cycle time. The old schwazzing method, while it increases the amount of light for that plant down to the lower levels, which increases the overall yield per square foot, can delay an 8-week plant into a 9-week plant or even more. And so by the time you lose that timing of cycle, you can actually end up with less yield over the course of a year. So you got to measure it, but the best way to measure it is just take the distance from the light to the top of your bench and what's the PPFD there, and then what's the PPF going to be when my plant is 5 feet tall. Mm-hmm. And then the balance of that's going to come from making sure that you're doing proper canopy management.
I've heard of people experimenting with intercanopy LED lighting. Any experience with that?
Well, the plant takes the light from the top up, not from the bottom or the sides. Yeah. It's going to actually start turning the leaves and stuff. I think that side lighting is probably better than lower level lighting, mm-hmm. and can help increase. But if you're getting enough from the top, there's no reason to do intercanopy. Unless, again, you're trying to really increase it, unless you got a very dense top canopy and you're trying to increase fruiting or flowering inside the canopy. That's why it's used for tomatoes. If you take a look at the tomatoes, you're trying to get tomatoes all the way down to the bottom of the plant. Right. So you're trying to provide intra-canopy lighting with tomatoes way more than you would do with a plant like that creates colas, like cannabis, or if you were to grow corn indoor. corn is very close to that as well. So it's plant dependent, and I haven't seen it have a lot of value with cannabis. Again, if you're defoliating, managing your canopy density, you shouldn't have that problem. Very, very good. I've seen it work very, very effectively, and we've used it. I do other than just cannabis. We've used it in lettuce with some side lighting on lettuce just to balance out the uniformity, and then also with tomatoes and cucumbers as well.
Yeah, and I in another lifetime I grew wine grapes, and we would do the same thing, leaf pull the canopy, to have light access the fruit, and it was unbelievable the difference it made in fruit ripening and quality of fruit is getting that light deep into the canopy.
It's because of the way that canopy is and the length of that plant. When you're growing a vine plant in particular, that intra-canopy is far more important than getting that power up to getting up to those top goals and stuff. So intra-canopy with vine plants, I think is very, very key and very important.
Okay, another question sent in earlier. It reads, I'm curious about hobby lights from a hydroponic supply store versus more commercial, higher price fixtures. Are there significant differences in the light output and efficiencies? Do lower end lights mean I need more, or is it the same type of canopy coverage?
So again, it kind of goes back to that balance. And one of the key areas is if you're a home grower and you're not supplying extra CO2, you're wasting almost all the light over 700 PPFD to 800 PPFD, for example. It's just a waste because the plant can't take it in because it can no longer get enough CO2 to create sugars and oxygen and everything else. So home growers, you can buy a lot less efficient light as long as it can deliver that PPFD you're looking at. And typically you're paying more for efficiency, more for PPF. So a home grower can get by with less light. You can't see it, but when I first started growing, I grew in the closet behind me before it became a toy room, and my wife didn't want that stuff in there anymore. And I had blurple lights, and I was growing with Emily's Garden that I found on Amazon.com by Googling hydroponics, similar to you did. And I was able to actually grow effective cannabis. Was it the best cannabis that you might want? No, you could probably get more terpenes and more THC out of it, but was it more than good enough for, like you brewing wine or beer at home or doing wine at home? Yeah. It was a decent product. So no, home growers don't have to spend more to get the most efficient lights unless they're getting all of those other balances, CO2 levels, water balances, heat, humidity. You can grow under fluorescent tubes. You don't need LEDs or anything. You can grow cannabis under fluorescent tubes but you want to be able to get to that 600 range at least in PPFD, and then over 800, it's not even worth it unless you're putting in CO2, in my opinion.
Okay, so next question. We've seen the advent of higher and higher wattages in LEDs. Where up to 1200 watts LEDs. Do you see that trend continuing in LED manufacturing?
Yeah, I think it's going to continue. We actually have lights. We can take the light that I developed at first for flowering, and we can go up to a 720 watt driver, for example. The increase in PPFD, you're getting, maybe for every 1% increase, or 5.5%, I think it is, increase in light, you get 1% increase in production. So that it starts to level out as to what you're going to get in that. The reason for the higher wattage is actually so that you can go with less fixtures. The biggest reason is when you're, for example, in a greenhouse and you're trying to get from shade avoidance, you can put in less fixtures that are putting out PPF. So if you got a light that puts out 4,000 PPF versus 2,000, you need half as many fixtures. But to get to 4,000, you need higher wattage. So it's far more prevalent in like greenhouses where you're putting the lights up higher and you're augmenting than what you're going to do in cannabis facilities and that sort of thing, because you end up with some height restrictions. You're not going to be putting in 20-foot rooms because that creates some other environmental issues for you, because you got to hang those lights that much higher as well.
Mhm.
John
Okay,
and
but,
Randy, there is another question that's come in through the chat.
oh, great.
Yeah, it says, new grower here, what would be the prime conditions for using LED lights? Temp, humidity, I've typically seen 75 degrees and 45% humidity. Can you elaborate?
Depends upon whether you're doing CO2 or not, but if I was growing back in my closet again with Emily's garden, and I did grow with LEDs in there, I kept that room, I would keep it somewhere around 75 and 45 to 50% humidity. You can have higher humidity levels, more water, and more light as you're adding CO2 and other factors to it. But for the home grower, that's fine. You can actually have a little bit higher temperatures than that. It's not going to hurt you too much, but once you go over 80, unless you're doing CO2, and you can end up with some heat stress on the plant.
Yeah, and typically we're seeing, again, at a commercial scale, injecting CO2, temperatures, upper 70s, lower 80s, and RH, between 55 and 60% is where we're designing.
You're trying to maximize your yield per square foot. When I was in the closet, I really wasn't worried about it because I usually grew more than I could ever use anyway. I was growing it for my wife at that point, and that's why we went over to Michigan, started over in Michigan.
Mm-hmm.
The grow room became a toy room. So,
well, Jamie, has any other questions come in? I can't see them in the chat, I guess.
There's just one other question. It's, as each strains have different genetics, can you standardize on all the 9 factors that were discussed earlier?
Not necessarily. I mean, you can, but you should be, as a commercial grower. It's harder to do it, by the way, as a commercial grower than it would be if you were growing in a smaller area, because it's harder to manage overall that environment. But different cultivars can handle light better. They can handle heat better. They can handle more. So yes, that will change based upon the cultivar, but not a lot if you're a commercial grower, unless you're trying to really create a couple of rooms that are just craft grows where you're trying to grow the best, highest quality THC and terpene levels, because the more exact that you have to be with the plant, the easier it is in a smaller space. So you can be more exact. So that's why you'll find that I know some top quality growers that have amazing product. I've got a friend of mine in Oregon that grows with living soil that gets over 4% terpene levels regularly. He can't scale his facility any more than the 40-60 pole barn that he's in. He just can't do it. He can't manage it right. But he gets enough for his product and it's good enough. So yes, the cultivars make a difference, but typically in commercial, not as much as if you're a craft grower with growing a smaller square footage, or a home grower. And craft growers, I typically, say less than 10,000 square feet of flower, and usually even less than 5,000 square feet.
I think it's a great question, and there's still so much research, so much experimentation to be done, particularly around the cannabis plant. I know when I was growing more traditional crops, there was so much research at your fingertips that you could access, and it could tell you the optimum conditions, the optimum fertilizer for whatever cultivar you were growing, of sweet corn, cucumbers, tomatoes. That is coming in the cannabis space, but we still got a while to go until our universities and colleges pick up that type of research.
Yeah, it's very difficult if you're producing a product and you're taking a risk by running a test on it. You're risking a lot of revenue potential. And the other problem is most people don't run tests properly. They'll go in and they'll change. So like if they've changed from HPS lighting to LEDs and they say, well, I got a better yield. I've also seen where all of a sudden they increase their CO2 at the same level, and they increase their watering, or they change this. You've got to have controlled environment testing to really come out with it. And again, that's easier done in small environments with less risk. Do you really want to go into a 2,000 square foot flower room that's yielding 75, 80 plus grams of flower per square foot and start risking changing your CO2 levels to see if you get more, and all of a sudden you end up with 50 grams? You just cost yourself a lot of money with your science project.
Yes, you did.
And there are no further questions.
Okay. Well, if we don't have any more questions, that brings us to the end of our webinar. I hope everybody found that nugget of wisdom. Randy, thank you so much for joining us today and sharing your thoughts and experience and knowledge around LED lighting. Thank you all for joining us. Remember, you will be receiving a recording of the webinar, a copy of the presentation. Please take a moment to fill out the survey. Also, again, with the ROI calculator, please email us at info@surna.com or contact us through the website at surna.com. Please do not hesitate to reach out to Surna with any further questions. We'd love the opportunity to put together a LED lighting quote for your next project. Thank you everyone again, and have a wonderful day.
Thank you.